All right. Good afternoon, everyone. Today, I would like to talk about my research, the effect of cementation on stress strain and energy behavior of sandy soil during undrained cyclic eroding. First of all, I would like to explain my research background, which is the liquefaction on Pleistocene sand. During the recent earthquakes, large amplitude was observed. Because of that, infrastructure company have been forced to reassess the durability against the earthquake of such important facilities such as nuclear power plants or highway. And the Pleistocene sand is not considered to be liquefied in the current liquefaction assessment method in Japan. However, based on the geological observation, physical and chemical stabilization induced by diagenesis can be dominant. So, but in terms of the geotechnical problem, geotechnical view, it is still unclear how both stabilizations affect the liquefaction characteristics of Pleistocene sand. So here is my objective. And there are two objects to be examined. One is the interlocking effect. The other one is the cementation effect. And then both effect will be quantified by the shear wave velocity measurement. And then I compare the liquefaction characteristics indicated by CRR or number of cycle or energy dissipation to shear wave velocity. And here is the methodology. I used the silicon number 7 and Portland cement as the base materials. And I changed the specimen preparation method and the cement addition rate as shown in here. And then after setting up the specimens, I put a pair of the actuators, a pair of the accelerometers to detect the shear wave. And then after the consolidation of 100 kilopascal of mean effective stress, I conducted the undrained cyclic eroding with constant amplitude. So let's move on to the result and discussion part. So this slide shows the result with different cement content. This is the C1% and this is C3%. So as you can see, the shear wave velocity increased to 220 to 360, and also number of cycle to be liquefied is increased from 6.5 to 16.5. So we can say, and as the many previous studies mentioned, as cementation effect increased, the shear wave velocity and number of cycle to be liquefied also increased. And this result shows the result with different specimen preparation method under the same cement content, which is C2%. So this is the wet damping method, and this is the dry vibration method. So as you can see, the left uppermost, the shear wave velocity increases the 300 to 420, and number of cycle also increases the 6.5 to 17.5. So based on those results, we can say that initial interlocking effect has a large impact on the shear wave velocity and stress strain behavior despite same cement addition rate. This figure shows the result from another perspective. The the lateral axis shows the normalized number of cycle, and the vertical axis shows the excess water pressure ratio or double amplitude of axial strain. As you can see in the blue colored area, the larger cement content, the faster excess water pressure ratio and double amplitude of axial strain develop in the region where the normalized number of cycle is less than 1. However, as you can see, orange colored area, double amplitude shows slow develop in case of higher cement content after initial liquefaction. So this is the schematic illustration based on the Kokusho 2012. So many previous studies were conducted in terms of the dissipated energy. Dissipated energy is defined the surrounding area, with the stress strain curve in EQ diagram. And then Kokusho in 2012 showed the relationship between the normalized dissipated energy and excess water pressure ratio is independent of density and fine contents. But a new question is arised. How about the cement content effect and the soil fabric effect? So this is my test result. The horizontal axis shows the normalized dissipated energy, and the vertical axis shows the excess water pressure ratio. And then the left figure shows by changing the cement content, and the right figure shows the one by different specimen preparation method. So we can see that all trends can be, although the initial part has a bit scattered, but we can say that interlocking and cementation has little effect to the entire energy and ratio, excess water pressure ratio relationship. So this is the summary of my test result. Based on the relationship, the shear wave velocity and the normalized, the number of cycle to be liquefied. So as you can see, the trend of the dry tamping and the dry vibration specimens is not along with that of the wet tamping specimens. This can be explained by the right side figure. So we think this unequality trend can be attributed to the difference in the interspatial arrangement between the cement particles and the silica sand particles. So this is the final result of our studies, which shown, so the horizontal axis shows the number of cycle, the vertical axis shows the CSR. So as you can see, in case of the C is equal to 0% or 1%, the less effect on the liquefaction curve was observed. However, C2%, in case of C2%, CRR of dry vibration shows the 1.5 times larger value than that of the wet damping. So we can say that the interlocking effect on liquefaction resistance is enhanced with increasing the cementation effect. So this is the final conclusion of our paper. Thank you very much for listening.